Bismillahirrahmanirrahim. I welcome you to CSC 339, Data Communications and Computer Networks. This is our lecture number 8. And today we'll talk about web and hypertext transfer protocol first, and then file transfer protocol, then email application, then proxy servers, and domain name systems. So let's begin our discussion with the web and hypertext transfer protocol. So until the early 1990s, the internet was primarily used by researchers, academics, and university students to basically log into remote hosts or to transfer file from local host to remote host and vice versa, or to receive and send news or to send electronic mail. But then in the early 1990s, a major new application arrived on the scene. Yes, the World Wide Web. It was proposed by Berners-Lee in 1994, and the web was the first internet application that caught the general public's attention or eye. Right, so this web, application is basically it operates on demand. Means whenever a user you want to receive, you decide, and when you want to receive it. It's obviously pretty much unlike the traditional broadcast radio and television, which forces user to tune in when the content provider makes the content available, and it's very easy. Any individual can access the information or can make the information available on the web. Anyone can access it using navigating through the ocean of websites, and we use forms, JavaScripts, and many other development tools to make the web more interesting. And especially these web-based applications or web servers are being used as a platform for many killer applications emerging after 2003. For example, talk about YouTube, talk about Gmail or Facebook, right? So the basic platform these applications are making use of is the web, right? And the web is basically based on Hypertext Transfer Protocol, HTTP, right? It's web's application layer protocol. What is HTTP basically? So this HTTP is the web's application layer protocol. Right, and its details are given in RFC 1945 and RFC 2616. So HTTP is basically implemented as in two programs. One runs on the client side, or we call it client program, and the other is called a server program, right? So the client program and server program, executes on different end machines. They communicate with each other to provide us the information to the user. So, before we go into the details, there are certain, a few concepts about the web that we quickly would like to look at. So first of all, in a web-based system, we have a web page, right? And this web page, basically, or a web page, basically, it's also called a document, right? It contains objects. Now, the next question is, what is an object in this scenario? So an object is simply an HTML file. Maybe these are JPEG images. These are some audio or video clips, right? That are addressable by a single URL, right? So the most web pages consist of a base HTML file, right? And which have several referenced objects. Okay, I mean we can access different objects that are on a base HTML file. So, for example, if a base HTML file has 10 objects, then how many objects we will get from the URL, for example, this URL that is given here. If we have, www.someschool.edu/CS department, and there is a base HTML file and then 10 objects. So how many total objects are there? 11, right? So one object is base HTML file, and the other 10 objects, maybe these are some images, 10 images there that we can access. Okay, and then obviously, other than that, we also have a web browser. So a web browser such as Internet Explorer or Firefox or Safari, it implements the client side of the code, right? Or the client side of HTML or HTTP. Specifically, if we talk about it in the context of web, okay? And then we also have a web server. So web server basically implements the server side of HTTP. It houses our web objects, as we discussed, that are addressable by a URL. Okay. So HTTP is basically, if a client is running a specific browser and wants to access a URL, so it will send an HTTP request to the specific server, either it's an Apache server or Microsoft server, right? And in response, the client browser will get what? Will get requested objects and also the information that how to display these objects, right? Similarly, a client maybe is running on a mobile, right? So again, we can access a collection of web objects by providing a URL, and in response, we'll get what? All the objects. But before making this request here, first of all, this client has to establish a TCP connection here, right? Between the server. Okay. So here we have to establish a TCP connection, right? So for example, this client needs to provide the IP address of the server, right? And what? And the port number of the port number for HTTP, which is 80, right? So for example, if this web server has this address, I just assume 152.16.17.10 and 80. So using this logical opening or a socket, I'll be able to create a TCP connection. And once the TCP connection has been established, right, then I can send HTTP request, and in response, I'll be able to receive what? I'll be able to receive the web objects, right? So HTTP is basically, it's stateless. Means the server maintains no information about the client request or the clients, right? On contrary, if you say that if server or HTTP is state oriented or it maintains state, so this means what will happen, that the server will maintain the past history of the client, right? What requests were generated, which specific URLs were visited, right? So if server client crashes, the view of the state may be inconsistent. So this is the problem with having HTTP state-oriented, that if a client is no more, or if a server has restarted or crashed, then the states won't be inconsistent. The information that was specific websites or URLs were accessed will be not consistent with each other, right? So as I mentioned earlier, that in order to initiate this request and response process, we need to establish what? The TCP connection first on port 80. Why? Because this port is reserved for hypertext transfer protocol, right? So when the connection is established, only then we'll be able to exchange the information, right? So there are two types of connections available using which we can transfer the data here, right? Either we can have a persistent HTTP connection, or we can have a non-persistent HTTP connection. So when we say non-persistent HTTP connection, this means that we establish a TCP connection, and once we have transferred the requested objects to the client machine, the connection will be closed. And if you want to access another, base HTML file containing, n number of objects, web objects, then you have to establish another TCP connection, right? So for every subsequent request, we have to again establish a TCP connection, right? So this is called what? This is called a non-persistent HTTP connection, right? Where for every request, we have to establish the TCP connection first, right? But on the other hand, if we have a persistent HTTP, this means after the server, after sending the base HTML file and all the objects on that HTML file will not close the TCP connection between the client and the server, right? So the TCP connection between the client and the server is still there. So this means if I try to access try to navigate another link on the web page, I do not need to again create a TCP connection. So this is called what? This is called uh, you know a persistent HTTP. Now, this is another discussion that you can configure modern browsers to control the degree of parallelism, right? That is, for example, what do you think if I'm accessing a base HTML file that has 10 other objects? Will I be able to download all these objects in a single TCP connection? So I repeat my question. There is an HTML-based HTML file, right? That has how many number of objects? 10 objects. What do you think? Will I be able to transfer all these 11 objects, the base HTML file plus the 10 other objects, in a single TCP connection?
सर persistent HTTP में तो हो सकता है.
No, forget about the persistent. I'm just talking about what about non-persistent, for example? No. So this means I have to create 11 serial TCP connections. How many number of serial TCP connections?
11.
11. Right? But as I was discussing earlier, that a user can configure the modern browser to control the degree of parallelism. That is, that how many number of parallel TCP connections you can create to get the web objects from a specific web server. Right? In the default mode, right, the modern browser can open, up to, it can open up to 5 to 10 parallel TCP connections. Okay, so that I'm talking about, the default mode, but obviously you can configure that how many, parallel connections you can create, right? Okay. Now, let's try to understand what's the difference between a non-persistent HTTP connection and a persistent HTTP connection. So let's assume that I want to access a URL, www.someschool.edu/department/home.index, and it has 10 JPEG images. What will happen first? So first of all, I need to establish a TCP connection. So the client side will request or will establish a TCP connection first. It will send a connection request first to the server, and server will acknowledge it, accepting its TCP connection request to establish a TCP connection at port 80. The client at step 2 acknowledges the the acceptance of the TCP connection, plus it also sends an HTTP request message, obviously containing the URL. Okay, and what will happen in step 3? In step 3, the HTTP server will send HTTP response message containing all the requested objects into its socket. And now here, if it is a non-persistent connection, non-persistent HTTP connection, which it is, so what will happen? We'll send, we will have 11 serial TCP connections. Okay. In one TCP connection, we'll send, base HTML file, and then so on and so forth, right? And then after sending the requested objects, the HTTP server closes the TCP connection. Okay, and on the client side, I'll take all the objects, I'll take the styling information given in the XML file, and I'll display the objects on the client machine. And now, if I want to navigate to another URL on the same web server, what I have to do is I again have to go through the step 1 to 5. Okay, means I have to again, establish a TCP connection, and then I have to get the requested object. So if I try to evaluate it in terms of the response time, so see what is happening here. So one RTT, by the way, this RTT stands for round trip time. This is what? Round trip time. This is the time taken by a small packet to go from this machine to the other machine, and then its response is received. Okay, this is known as round trip time. So one RTT is required to establish the initial TCP connection, right? So where we send a TCP request. So this is a TCP connection request. Okay, and server accepts it, right? So here is the acknowledgement from the server. The server has accepted the request, and this is what? This is one RTT, okay? And then the client machine acknowledging the acceptance of the request from the server, plus sending what? HTTP request message. Okay, and then what happens in response? The time that is required to complete this request is one RTT, that is to receive a response from the server here, plus you can see notice in this timeline, plus the objects that we have requested. I mean, how much time is required to receive this file depends upon what is the size of the objects that we want to receive. So if we ignore this, so fundamentally, how much time is required to get a response from the server in a non-persistent HTTP connection? So 2 RTTs there, right? So one for the initial TCP connection and 1 RTT for the HTTP request and response, plus the response time will be decided on the file, on the file size here, right? I mean, how many number of objects that we are, and what is the size of the object that is being sent from the server to the client, right? So this means every time I want to access another URL, I have to have this 2 RTT time is required to first establish a TCP connection and then to request a specific URL file. In contrast, if I try to look at the persistent HTTP, what is happening? So after sending the object or entertaining the request, server does not close the TCP connection. Right. So this means what? Again, we can generate the subsequent request. So what is happening here? So this means we can receive 1 RTT for all the referenced object, right? So for every reference object, I do not need to create a separate, a TCP connection again. So if I look at the HTTP request, it contains basically 2 things. It contains a request line, and then it contains a header line. Every line is in this message or request is terminated with a carriage return and line feed here. You can see here, right? So the first line tells me the request, what sort of request it is. Either it's a get message, it's a get command, it's a post command, or it's a head command, right? And then we have the host, okay, URL, and then we have the user agent. Either I'm using Firefox or Safari or Internet Explorer and its version. Why it's important? Because certain web servers have different displaying information for, or the formatting information for the different web browsers. And then we have this, the language here. Either I want to see the information in English or in Urdu if it is available on the server, and then the coding information there. Okay. So what happens in response to this is that the server will send me the requested object, and we have different sort of methods there. For example, post, in which what we do, we can input the data in terms of in a form, right? Or input is uploaded on the server, or we can, we have this URL method using which we can upload something in the URL field, and for that we use what? We use this get method, right? And before I move on to the proxy servers and the next application, the application layer, I would like to talk about how the user server interaction is managed with the help of cookies, right? So is it visible to you?
Yes, sir.
Okay, good. So as we have discussed earlier, that this HTTP server is stateless, right? Means the server does not maintain any state about the user request. Obviously, this simplifies the server design, and it enables the software developers and engineers to develop high performance web servers, which can or that can handle thousands of simultaneous TCP connections. But nowadays, it is also desirable for a website to identify to identify users. Why? Because the server wishes to restrict users' access, or because it wants to serve content as the function of user identity as per my preferences or as per my previous interest while I was browsing a specific web server, right? So the thing that I want to discuss with you is it's basically user server interaction. And I want to talk about cookies. Okay, so so for a web server to be aware of a client's previous activity, HTTP uses cookies, right? And the cookies are defined in RFC 6265, and it allows a site to keep track of users, right? And most importantly, most major commercial websites use cookies today, right? Why? I mean, obviously, we know that it gives them an edge to present the most relevant information to the to the client. So the cookie technology has four components. Number one, it has a cookie header line in the HTTP response message. It has a cookie header line in the HTTP request message, and then it has a cookie file kept on the user's end system and managed by the user browser. And number four is it has a backend database on the website. So it has four important components. If I talk about cookie technology, number one, it has a cookie header line in HTTP response message, right? So we have a cookie header line in HTTP response, and then we have a cookie header line in HTTP request. And number three, we have a cookie file that is kept on the user's end system. And is managed by user's browser. And managed by user's browser. And then we have, a backend database at the website. So let's see how it works, right? So we'll take an example, a scenario to see how cookies work, right? So let's assume that we have a host here or a client machine. So here we have a client, and then we have a server here. And let's assume the server is, Amazon. Okay. So here, this is the timeline increasing downwards. And let me assume that this client has already accessed eDiv, first, and it has been assigned, or it has a specific cookie, right, or record ID that is, and it was given by eBay, and it is say 8734. Okay, and now this client visits Amazon by sending, HTTP request message. So this is a usual HTTP request message. Okay, and when this message is received by the server, here the Amazon server, creates the server. The server creates ID for the user, and let's see, the server assign ID 678 to this machine or the user, right? For user, right? And you know what? This is also maintained in the database. Okay, and the and a simple regular usual HTTP response is generated by Amazon. So this is HTTP response message. Plus, it also sets the cookie, or it also sends this information to the client browser that set cookie, the ID that was assigned to this client, which is 1678. And what happens on the the client side, the browser update this information here. It knows that that Amazon has assigned it ID or cookie 1678, and it was already having a cookie, or maintaining a cookie for eBay, which is 8743. Okay. Now, it again, this browser wants to, browse for something on the website. So it again sends what? It again sends a usual HTTP request. So this is usual HTTP request message. Okay, but when this message is sent, it also send cookie information, or the identity that was assigned, or the ID that was assigned by the Amazon and is maintained by the browser. So this is what? So the cookie is 1678. Okay. Now let's assume that after a week, after a week's time, the machine again sends a request to the server Amazon, right? And again, again the cookie is, this is again usual HTTP request message. Okay, and the cookie here is 1678. Now, when this request is received, right, or even when this request is received, the server performs cookie specific action. So here, the server will perform what? Cookie specific action, right? So it will use this cookie to access from the server that what specific websites were visited by the by a specific client, means what specific products were browsed, so that next time, again, when this request is generated after 1 week, again, based on this, cookie specific action. It sends this information to these database and gets the information about the the products that were visited or the products that the client were interested in, and it generates a response, right? But now this response, yes, it is a usual HTTP response, but now this response contains what? This response contains information that is based on the interest of the user. Okay, I mean, the cookies. Yes, the cookies have revolutionized the internet shopping experience, right? Because I will be getting information about my previous, accesses, right, or the previous history of on a certain website, right? But on the other hand, the cookies are controversial. Why? Because they can also be considered as an invasion of privacy. Like, for example, as we have just seen that as a combination of cookie, a user will be supplied, user will be providing account information. So our website can learn about a lot about a user, and a website can potentially sell this information to a third party, right? So this means that there are a lot of issues with the cookies as well. But anyways, at the moment, if we talk about the the internet commerce, the shopping experience, and if we talk about the famous commerce platforms such as Amazon, eBay, and many other websites, the most of them are managing the user interaction with the help of the cookies here. Okay. चलें, हम क्या कह रहे हैं कि वेब कैशे वेब प्रॉक्सी सर्वर्स क्या हैं? That whenever we have a request, जैसे ये client है, ये request करता है किसको? Amazon को, तो पहले request किसके पास जाती है? Proxy server के पास, right? नजर आ रहा है आपको? And we assume, just for the sake of understanding, that no copy of similar request is available at the proxy server. So HTTP request will be forwarded to the original server, and original server will send the requested object to the proxy server, and the proxy server will forward it to the client machine, and also will maintain a copy of it at the at itself, right? Will maintain a copy of it, right? So next time, if another client is coming in and the client requests the same object, what the proxy server will do? It will not forward the request to the original server, right? And will return the reply. And let's assume that we have many such clients. They try to access the same object, so every time we do not need to forward it to the original server. So the proxy server or the web cache is very important. Why? Because it is it is limiting the traffic on your internet access or internet link. So on your access link, what we are trying to do is we are trying to minimize the traffic. Okay. So imagine every time we are sending the request to the original server, this means there will be a lot of traffic on this internet access link or the internet link here. Clear? And this proxy server acts as a client and server at the same time. It acts as a server when it sends a response to the client, and it acts as a client when it sends a request to the original server. Okay, so this proxy server is acting as a client as well as a server, right? And it's of absolute importance, right? Otherwise, every request will be forwarded to the original server. Okay, is it clear up till now?
Yes, sir.
Okay, good. And I was discussing that through the use of content distribution networks, so using what? Using content distribution network, the CDNs. The web caches are increasingly playing a very important role in the internet, right? So what happens nowadays is that content distribution network company installs many geographically distributed caches throughout the internet. Why? Because they localize much of the traffic, right? So we have like shared content distribution networks. We have dedicated content distribution networks, such as Google and Microsoft have their dedicated, content distribution networks, right? So what we are doing is we are trying to localize the traffic. And if you look at from the perspective of from the perspective of a institute or a company or an office, so we are not sending every request out of the office or an institute every time. But obviously, uh, you know, uh, uh, obviously there is a problem here. The problem is, or the question is, the copy of an object residing in the cache is maybe not updated. I mean, maybe I'm maintaining a copy of an object here, the proxy server, but that object has been updated at the original server. So the question is, am I getting the updated copy? Am I getting the updated copy of the object I'm trying to access? Right? Yes, this is an issue, and in order to handle it, we have a conditional get mechanism uh, 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 to make sure that the object that is being forwarded by or that is being provided by the proxy server or the web cache is updated, right? So what I'm saying is, in order to resolve this issue, that I get the updated copy of the object that I'm trying to request or I'm requesting, we have for this conditional get mechanism, right? So using this conditional get mechanism, an HTTP request, ensures that latest or updated object is being provided, right? So what happens with this is that the request message uses the get method first of all, and the request message also indicates that an if modified since it's a new command or a line that is added into the HTTP request, right? So what I'm saying is that a new line is added, in the request message, and this says what if modified since, right? And we add it in the header, and this tells us that um, uh, when was the last copy saved on the the cache. And when I get a response from the server, it also includes what? So this is on the client side. So when I receive a response from the server, it also has an additional line in the reply that is last modified. Last modified. So if there is a difference of date in there, so this means it is not the latest copy on the proxy server, and in this case, the proxy server has to get the fresh or the updated copy from the original server. So are you getting my points, right? So obviously the web cache is very helpful in order to localize the traffic, using content distribution networks, and we have open content distribution and proprietary content distribution networks, dedicated, content distribution networks, which is true in the case of Google and Microsoft. But whenever we are using proxy server, there's a question always there that the copy of the object that is being provided by the proxy server to a client is either updated or not. And in order to resolve it, we have this conditional get mechanism. where we have a line in the header, HTTP request header, if modified since where the date when it was stored on the proxy server, and the server also sends up an object where it mentions the last modified, so that we can identify that this object needs to be refreshed on a proxy server or web cache. Okay, and remember again, before establishing this connection, what we have to do. Before we can send a request to proxy server, what we have to do? We have to establish a TCP connection again, right? Again, first, a TCP connection will be established between the client and the proxy server, or the proxy server or the original server, right? And then we will be able to send a HTTP request, and we'll be able to get HTTP response. Are you getting my point?
Yes, sir.
Right? So the HTTP connection is a must. So first we have to establish, a TCP connection is a must. So first we have to establish a TCP connection, and then only we'll be able to send HTTP request to proxy server. Whether it will be forwarded to the original server or not will be decided that does it have the copy of the requested object. If it does not, again, it has to establish a TCP connection first with the original server, and then it will send a forward HTTP request and will be able to get HTTP response. Right. Okay. The next application that I want to discuss, is FTP, file transfer application, and the protocol that is used by such applications is called file transfer protocol. Okay. So this file transfer protocol, it has three basically components. First we have the user. First we have the user host, or the FTP user interface here, right? And then we have the FTP client side, and then we have the server, where we are storing the files, or where we can upload a file, or where we can download a file from, right? So details of RFCs are there in RFC 959. The FTP, we established two TCP connections in order to make a transfer from server to the host, or host to the server. So instead of one TCP connection, here we have how many number of TCP connections? We have two TCP connections here. So if I want to make a transfer on this FTP, first I will establish a TCP connection on port 21, right? And this TCP connection is for or is called control connection. Control connection means what? That it will contain all the control information, such as identification, passwords, command to change remote directory, command to put or get files, right? So these are all different control commands here. So it will establish a TCP connection through which we'll send passwords, usernames. We will set commands to change the directory, or to put or get files command, right? And actual data will be transferred from a FTP client to an FTP server, or from FTP server to FTP client, will be made on another TCP connection that is established on port 20. So this connection is for data transfer. So if I want to use TCP, it has what it has. I need to establish if I'm using an FTP application, I need to establish two TCP connections. One for the control information on port 21, another for the control information on port, well, another for the data, transfer on port, port 20, right? Since we, we have two separate connections here, the control information is set to be out of band, right? What we call it, out of band, means we have a separate, TCP connection for sending the control information, and I've already explained what a control information contains, right? In contrast, and just to understand out of band, in contrast to this, HTTP is set to be in band. I mean, why? Because it sends the control information in using the same connection. So in contrast to FTP, HTTP is, that we have just discussed, HTTP is basically in band. In band means what? In band means that it sends its control information on the same connection, and we call it out of band FTP. Why? Because we have a separate TCP connection that is used to send what? That is used to send the control information separately from the data information. And also the FTP server needs to maintain the state about the user, right? Where HTTP was stateless protocol, here the FTP is to maintain the state of the user. So that's why we also call it what? Stateful, right? In contrast to HTTP. Okay, so this is how file transfer protocol works by establishing two TCP connections. So I hope that you are noticing that every time we are using or we are discussing an application layer application, first of all, we have to either establish a TCP connection or maybe the UDP connection that we'll see in a minute. Then only we'll be able to use or send messages using a specific network application. Okay, let's quickly talk about the electronic mail. So internet mail has been around since the beginning of the internet, right? And it was the most popular application when the internet was in its infancy, and still it's getting more and more powerful. It has different components. There are three actually components that we need to understand in order to see how electronic mail or email works. So we have a user agent, and then we have a mail server, and then we have simple mail transfer protocol. These three, are important components. So a user agent is basically, maybe a browser, right? That is used to compose or edit or read email messages. It is maybe a third-party software such as Outlook, Thunderbird, Apple email, or maybe if you're accessing your email using web browser, it's a web browser. Okay, so whenever we have to transfer, information between, so here is the user agent. Maybe I'm running, Apple Mail here, or maybe Outlook, or I'm using web browser, whatever. And the second entity is the web server, such as Gmail or Hotmail, where the messages are being maintained, are stored. And whenever I have to the transfer message from user agent to the server, or maybe from one server to, for example, this is Gmail server, and here I have server of Yahoo. So for that, I need to have this simple mail transfer protocol, SMTP, right? So whenever I want to transfer email in between the different servers, I need to make use of simple mail transfer protocol, right? SMTP, right? So mail servers are very important because here the the messages are maintained or queued or are managed or searched it's very it's getting powerful day by day. Okay, so let's try to understand SMTP and the working of SMTP uh, with the help of an example. And let's see that Alice here, Alice here wants to send a message to Bob. Okay, so here we have Bob. So Alice wants to send message to email to Bob. So Alice has this user agent, right? So Alice needs to use this user agent first of all, and will compose an email to Bob and will address it to Bob at some URL, say Bob at Bob at hotmail.com, right? So Alice user agent send messages to message to this to the queue of Alice email server. Say let's assume that Alice is using Gmail, right? And Bob is using what? Hotmail. Okay, so the message will be queued on the server of Alice. So whenever it's done or it's time to be transferred, it will establish SMTP, right? Using SMTP, it will establish a TCP connection between these two mail servers. So what is happening here is that this transfer at step 4 will take place using SMTP, right? Simple mail transfer protocol. But for that, it has to establish a TCP connection first on port 25. Okay, so this transfer, this step number 4, is basically the transfer of data from Gmail, which is Alice email server, to Bob's email server using SMTP, Simple Mail Transfer Protocol, and it will establish first a TCP connection on port 25, right? And then the message is received by the Bob's email server, which is Hotmail, right? And it will be queued, and Bob can anytime come and read this message, right? So you can see, so whenever we have to transfer, it's important here, whenever we have to transfer a message from, say, user agent to the email server, say gmail.com, I need to use Simple Mail Transfer Protocol, and that will basically will establish our TCP connection on port 25. Again, from Gmail to Hotmail, I'll make use of what? SMTP, but again, a TCP connection will be created between the mail servers of both Alice and Bob. And the next question is, what do you think? How Bob will get messages from here? Yes, what do you think? Because see, this SMTP is a push protocol. SMTP is what? A push protocol, right? That is that the sending email server pushes the file to the receiving email server. So Gmail pushes the file or the message to the Hotmail server. But how? The question is, and how Bob is able to access the email? For that, Bob uses what? Bob needs to use what? Mail access protocol, right? And this mail access protocol, there are a variety of options there. So there are two important protocols here. We have POP, that is post office protocol. This version is 3 that is being used at the moment, POP3. Or the alternate option is IMAP, Internet Mail Access Protocol. At the moment, its version is 4, IMAP 4. So either Bob will use POP3, Bob's user agent will use POP3, Post Office Protocol 3, or IMAP 4, Internet Mail Access Protocol 4, to access email from the Hotmail. Why? Because SMTP is a push protocol, so there is no mechanism here to push email to user client here or the user agent on the Bob side. So Bob needs to make use of what? Bob needs to make use of any of these POP3 or IMAP4 mail access protocols, or either Bob can make use of what? Simple HTTP, right? We know that nowadays Gmail, Hotmail, Yahoo, and all the emails are also providing the HTTP based access. So because HTTP is a pull protocol, so we can get the information email using what? Using HTTP as well, right? So this mail access protocol is important, right? Because once the SMTP delivers the message from Alice mail server, that is Hotmail, to Bob's Gmail, to Bob's email server, that is Hotmail, the message is placed in Bob's mailbox, right? And it's important to see that how it is extracted. It is extracted using what? Using the mail access protocol. So mail access protocol, defines how the messages are being stored, managed, and folders are being maintained, on the user agent or email server. For example, the difference in POP3 and IMAP4 is that using POP3, Bob will be able to get all of the messages and can maintain local folder directory, and can access it offline from its user agent or from using its machine. But if Bob wants to access this again from another machine, it won't be possible. So for that, we have IMAP, where the folder maintenance and everything can be done on the server. I can access all the messages and directly from the server whenever is required. And secondly, using POP3, a complete message is transferred to Bob's user agent, containing the header plus the body and the attachment and everything. When I talk about IMAP, so IMAP only delivers first header of the message, where it contains the information like the messages coming from, to its subject, and then when I click on the message, then the rest of the body or the attachment is received or is obtained from the email server, right? So the next topic is domain name system that we'll cover in the next class. So that's it for today.